Dear colleagues, friends, students, ladies and gentlemen, on behalf of our research team, I would like to thank the paper assessment panel chaired by Dr. C.K. Lau for giving us this award. We are extremely honored. In addition to the significant contribution made by my 4 co-authors showing in this slide, I would like to acknowledge a number of silent heroes behind the scene, but contributing towards this paper. They are Engineer W.K. Poon, former head of GEO, Engineer Dr. Raymond Zhang, the current head of GEO, Dr. Susanna Kaas from NGI, and Professor Cui Peng from the Chinese Academy of Sciences in the mainland. Without their support and advice, we could not possibly have obtained the funding to carry out the research work presented in this paper. And also, I would like to thank them for their active participation in this research project. This paper was an invited plenary lecture presented orally at the 5th World Landslide Forum, organized by the International Consortium of Landslides under the UNESCO. The written version of this paper was published in the proceedings called Understanding and Reducing Landslide Disaster Risk, edited by Professor Sasa and his team. If you're interested in our paper for your own research and teaching purposes, you may download it from our AOE website shown in this slide, slope-aoe.hkust.edu.hk, or simply scan this QR code shown on the screen here. Now let me briefly introduce the technical aspects of our paper. What is a debris flow? Just in case you are not very familiar with it, let me show you a number of short videos to illustrate how devastating damages that can be caused by debris flows around the world. This is the one took place in Brazil in 2008.
왼편 우면산 쪽에서 엄청난 양의 토사와 물이 쏟아집니다. 바로 앞에 있던 차량들이 순식간에 사라졌습니다. 일촉즉발의 순간, 여씨는 급히 제동장치를 밟았고 토사가 유리창에 튀었지만 차량이 휩쓸려가는 것은 간신히 피할 수 있었습니다.
This one from the United States in 2012, walking down the moving cargo train. This one took place in Hunan province in 2016 in the mainland. A more recent one took place in Fujian province in 2019. Rigid and flexible barriers are commonly used to protect our community against debris flows. To mitigate large volume of debris flows and to decelerate flow velocity, multiple rigid and flexible barriers can be considered and also, I think, should be encouraged. And however, the design of either single or multiple barriers is essentially empirically or semi-empirically based, leading to significant uncertainties in the design of multiple barriers in particular. Personally, I think multiple barriers, particularly the flexible ones, should be used in congested cities instead of a large or huge terminal barriers installed at the bottom of a hill slope. This is because multiple barriers can decelerate flow velocities right from or close to the source, and hence reduce the size of barriers needed downstream, and also reduce carbon footprint, which is a very important issue these days. Also, because of their relatively smaller sizes needed, they can be easily blended with the environment, and hence it is an environmentally friendly solution. Now let me show you a video recording during a flume model test involving 2 rigid barriers. What you're going to see is a debris flow flowing from the top right-hand corner, hitting the first barrier, climbing up and overflow the first barrier, landing on the flow channel, approaching the second barrier, climbing up, and then overflow the second barrier. Now, if you are the design engineer, how would you determine the impact forces for the first second, or even the third or fourth barriers safely, scientifically, and economically? Also, how will you determine the barrier height and spacing between two consecutive barriers for the design of multiple barriers safely, scientifically, and economically? If you want to know the answers, please take a look of our paper, which provides you a theoretical framework here and analytical solutions to guide you to do the design calculations. Also, we provide you details of verifications of our analytical solutions with our test results from our 5-meter long flume and 28-meter long flume test, together with our design recommendations for single and dual barrier system with and without basal clearance. Thank you for your watching.